We're not just redefining how wheels are manufactured, we're exploring design ideas that were simply infeasible or even unimaginable with current technology. Currently, the way HRE makes their wheels is we take a 100-pound forging and we're going to machine that down to about 20 pounds. And so it's a pretty involved and expensive process. The reason HRE wanted to work with GE wasn't just because we knew they made great additive machines. With their expertise on the material science side, they understood the titanium powder really well. They understand the process that's needed to take that powder into an actual part.
GE Additive understands the process of taking an intimate knowledge of what the part requires from a quality and performance perspective, backing that up into how we need to run the process. But GE Additive has an intimate knowledge of all three of those key steps.
This project's important to HRE because we're known for our innovation and exclusivity. But if you look at the process around making a forged wheel, it's a very expensive, time-consuming process, and we want to be looking at new materials and looking at additive technologies. Those are the things that are on the horizon.
GE Additive has a much deeper background in materials development, going back to our teams at GRC or even in aviation, where our teams have been developing alloys for a long time through all sorts of manufacturing techniques. So we understand what it takes to not only develop good materials, we know how to analyze the materials, and we even get into the very, very minor details.
In the performance space, titanium is sort of the holy grail, right? It's that thing that everybody wants. It's super strong, corrosion resistant. It's almost ideal for a wheel. In the past, HRE's worked with carbon fiber, and carbon fiber is on the market. And titanium has actually been a little bit more elusive because of the cost involved and the difficulty in manufacture.
The goal of this project was less about producing a wheel for the market. It really was a concept of wheel to really show the possibilities of additive manufacturing.
What we're looking to do with HRE is really redefine how wheels are manufactured. The current process of taking a wheel forging and aluminum forging and machining it away, it's very expensive. It takes a lot of time. It does give you a beautiful component at the end, but what we're trying to do is change the material game.
I think what was really interesting for us on the design side was looking at the capabilities of additive. You know, you think of additive, there aren't a lot of limitations.
The design of this wheel was a lot more challenging because we've never designed for additive before. So we had a lot of new learning that had to take place. We didn't have to worry about draft angles. We didn't have to worry about lathe profiles. We didn't have to worry about tool depths because there are no tools in additive manufacturing.
So the process that we're using here is called electron beam melting. This is an additive manufacturing process where parts are made by melting a bed of powder on top of a build plate, layer by layer, until your parts form. In terms of prep, what you have to do is you have to add thermal supports and then also slice the part. What slicing does is you take your CAD geometry, your 3D model, and you slice it up into two-dimensional geometry. Because it's an electron beam, the process is very quick. Ultimately, you can print very large parts very quickly when you compare it to laser or other type of processes that are similar. The powder recovery system takes powder of the same material, and it's like a grip blaster. It takes that powder and helps you blast away the semi-sintered powder cake, leaving behind just the fully melted part. You still have a lot of thermal supports that you still need to remove from that part. Typically that's done with hand tools, so you can either break it away by hand until you're left with just the part without any supports.
You can't just take any design and put it into a pattern and make a good wheel. And at the same token, there's a lot of design rules for additive that we need to relay to the customer. And this marriage back and forth between what makes a good wheel design and how can that design be adapted for additive is really what makes this involvement with HRE more interesting.
Additive manufacturing gives us a lot of freedom to do a lot of different things that we aren't normally able to do with traditional machining methods. It opened up a lot of opportunities for different shapes, different surfaces, and different techniques. For example, the interlacing of spokes, hollow areas around the wheel. even the multiple parts as something that we've never done before.
So while we know the size capability of the machines coming in the near future will allow us to print a wheel as one piece, when we did this project, we needed to break the part up into 6 individual pieces.
This wheel will look a lot different than any wheel you've ever seen before, and additive manufacturing allowed us to do some of these shapes.
What excites me most about this project is really the opportunity to see additive manufacturing come to life in an area that you normally wouldn't see it or haven't seen it before.
After going through this process with GE, it really opens your eyes as to the possibilities in wheel design.
Customers like HRE Wheels are a perfect example. They're getting in front of the competition. They're moving down the additive path now.
Throughout this project, it's been really exciting, and to see the final wheel, I mean, it's insane in a wonderful way. I think it's like nothing else out there, and we're excited for the future.